Hello, today we're going to be looking at how to write and balance a half-cell equation. This has to do with pretty much knowing how to write a decomposition reaction. That's pretty much what an oxidation number is. And a reduction is nothing more than a synthesis. And it's really what side of the equation or arrow do you put the electrons on. So to get started, the first thing is on tonight's assignment, we're going to take a look at what underwent change. I don't see any number on this lithium that's sitting right here, and I don't see a number on this, so those are the elements. So I'm going to give them a 0. And I'm going to try to observe what kind of change went on between here and here. Now, this is going to sound kind of scary because you have to know how to count to figure this out. Did the number go up or did the number go down? 0, positive 1. I hope your answer is going to be the number went up. So when the number goes up, we call that oxidation. Because, for instance, if you were working a job and the boss said, hey, we're going to give you a reduction, and you started smiling, saying, awesome, I'm getting a pay reduction, then there's something wrong. You don't understand what the word reduction means. Reduction means the number goes down. So looking at the other one that we have here, we have calcium. And we can see that that number went down. So back to our thing here, I usually put the oxidation first. Now I'm going to copy out what happened here. I'm going to write that lithium that's on the left-hand side. On the left-hand side. I'm going to then draw the arrow and say what lithium became on the right side, and that is lithium plus 1. How did it do that? To go from 0 to 1 on a number line is 1 space, and that's why it only took 1 electron to do it. So keep that in mind, guys. We've already worked on these before when we looked at what a metal was going to do and what a non-metal traditionally does with electrons. So keep that in mind. We've already looked at this issue. This is not a new issue. So now I'm going to take a look at what calcium did. I see calcium right here on the left-hand side as a positive 2. It's going to gain 2 electrons, and then it's going to become calcium 0. If you look mathematically at what's happening, what we're saying in the oxidation is as follows. We're pretty much saying 0 equals, and that covers this and this. The other side of the equation is saying plus 1 plus a minus 1. If you think about it, 0 equals 1 minus 1. If you look at the reduction, when we look at the reduction, algebraically, I guess we'd be saying this, plus 2 minus equals 0. And that's the same thing, saying 2 minus 2 equals 0. Hopefully that is a helper in helping you put this together to kind of clean this up so you can see exactly what's going on here. So this does not look confusing. To recap, what I basically did was I first saw what underwent change, what went up, what went down, and I pulled out only the components that went up. And if you take a look at my reaction here, I'm only looking at lithium. I did not put anything else in the equation other than lithium, because lithium is the species that went up, calcium is the species that went down. The last piece that we have to do is electrons that are lost from one reaction, which this is right here, electrons, how can I write this in shorthand? I'm going to write this like this. Electrons, oxidation is losing, and I'm going to write reduction is gaining, and that's what we're seeing here. Oil rig. All right, well, anyhow, the reactions also need to be balanced because the amount of electrons don't match. So what I see here is that the lithium equation should be multiplied by 2. so that we get a total count of electrons that would match. So anywhere in the master equation up here, I would put a 2 in front of the lithiums, I'd put a 1 in front of the calcium, and that is how to do the homework tonight.